In this lesson, we are going to learn about probability with and without replacement. The first type of problems we're going to do are the ones with replacement. That means if we are doing a problem with compound events that have two different events, if we pick something out of a bag or out of a box, we are going to replace it before we do the second event. So the first event, we might pull a Skittle out of a bag and then we will put it back, or we'll replace it before we do the second trial. All right, so the first problem says Makiva has a baggie with 5 red Skittles and 4 green Skittles. What is the probability that she picks a red, puts it back, then picks a green? So this puts it back is a key thing to pay attention to. That means with replacement. So I'm going to set up my problem, and I'm going to read my question again. And it does say she picks, what's the probability she picks a red, puts it back, then picks a green? All right, so I'm going to write a note. So what's the probability of picking a red? Then she'll put it back, and then she'll pick a green. All right, so I'm going to draw my bag. So right here, as you can see, I say draw your bag. So I'm going to just draw the bag. Doesn't have to be pretty. And I'm going to put my 5 red and my 4 green. And now I'm getting ready to put my hand in the bag. So at random, you put your hand in the bag and you pull out 1 Skittle. And you're trying for the red. So what's the chance of getting a red? Well, 5 out of a total that's in your bag of 9. Oop, I forgot to draw the total. So I like to total the number in the bag too. So 9 total. All right, so the first probability of getting a red, that's the first thing we want to do, is 5 out of a total of 9. And if it's compound probability, we're going to multiply that probability by the second event, the second thing we do. All right, so we're going to put that Skittle back. So we still have 9 Skittles in the bag, 5 red, 4 green, and we're going to put our hand in again. And this time we're going to try for a green Skittle. So what's the chance of getting a green? Well, there's 4 green Skittles in the bag, so 4 out of 9 total. So 4 out of 9. All right, so now, so to get my final probability, I will multiply 5 times 4. So multiply 5 ninths times 4 ninths. So 5 times 4 is 20. And then 9 times 9 is 81. So over 81. And I actually cannot reduce that fraction anymore. So my probability is 20 over 81, or 20 81st. 80. So that is the probability 20 times out of 81 tries that I would get a red then a green. Or if I can change that into a percent too. So 20 divided by 81 is 0.2469. So I put 20 divided by 81, 0.2469. And if I change that to a percent, I move the decimal over twice and add a percent sign. So that would be 24.6, or I could round that to 24.7%. So that would be unlikely for those two events to happen. All right, problem 2. Andrew has a baggie with 1 red Skittle, 3 blue Skittles, and 2 green Skittles. And I drew my bag right here. 1 red, 3 blue, 2 green. Always draw a picture for your problem. What is the probability that he picks a blue, replaces it, then picks a red? So again, we're going to, if we take one out for a second event, we're going to replace it before we draw the second Skittle out. All right, so I'm going to find the probability of picking a blue, replacing it, then picking out a red. All right, so what's the probability of picking out the blue first? Well, there's 3 blue. So 3 blue, and I forgot to total my bag, so we have 6 in the bag total. 1 plus 3 plus 2, 6. So probability of getting the blue is 3 blue out of 6 total. So 3/6. All right, times, what is the probability of getting the red? Well, first of all, we're going to put that blue one that we took out back in, and so we still have the same amount in the bag, and now we're going to pick out a red. So the probability of getting a red is 2 out of 6. All right, now before I multiply these fractions together, I'm going to reduce them. So 3/6 can be reduced to 1/2. And I know 2/6 can be reduced to 1/3. So I could divide by 2, divide by 2. All right, 1/3. So now 1 times 1 is 1. 2 times 3 is 6. So the probability of both of those things happening is 1/6. And if I wanted to change that into a decimal, it would be 0.166, repeating, oops, that's two, or 16.6%. All right, problem 3. A jar has 2 pennies, 2 nickels, and 2 dimes. What is the probability that Evelyn will randomly pick out 1 nickel, replace it, again this is a with replacement problem, then pick out 1 dime? All right, so what I want to try to find is the probability of picking out 1 nickel and replacing that nickel and then trying to pick out a dime. All right, so I drew my jar already, and I want you to draw your jar too. So I've got 2 pennies, 2 nickels, 2 dimes, and I totaled them up, and that's 6 total things in the jar. So 6 different outcomes, and here is what I have in the jar. All right, so we're gonna first, it says try to pick out 1 nickel. So what's the probability of picking out a nickel? Well, I have 2 nickels out of 6 total, so 2 out of 6. Then I'm going to multiply that probability with the next thing I'm trying to do. I'm trying to now pick out a dime. So I replace my nickel, put it back in the bag, so I still have the same amount of things in the jar. Sorry, not in the bag, in the jar, and 6 total. So picking out a dime, I again have 2. So I have 2 chances out of 6 to get a dime. So now, before I reduce those or multiply those, I'm going to reduce 2/6 to 1/3 and this 2/6 to 1/3. So now, since I've reduced the fractions, it'll be easier, so I won't have to reduce at the end. So 1 times 1 is 1, 3 times 3 is 9. So my probability is 1 out of 9 times that 1 out of 9 chances to first pick a nickel out, then a dime out. So it's probably unlikely that that would happen because 1/9 is... All right, so if we figure out the probability was 1 chance out of 9 of these 2 things happening in a row, and it was a multiple choice question, I didn't see 1/9, but I saw either this decimal or this percent. Remember, we can express probability in each of those 3 ways: fraction, decimal, or percent. So if I got 1/9, I would just, if I didn't see an answer that was in fraction form, I convert my fraction into a decimal by dividing 1 divided by 9, and I get 0.111, and I can change that to a percent easily also by moving the decimal. All right, see if you can try this one on your own. All right, so I drew my jar, and hopefully you did too. I totaled it up, and I have 11 coins total in the jar. So the probability of picking a penny, putting the penny back, replacing it, and then picking another penny out is, let's see, the first penny is 2 chances out of 11. So 2 elevenths. Then I'm going to put that penny back, and I'm going to try to pick out another penny, and that also is the probability of 2 out of 11. So we're just going to multiply those probabilities, and we get 4. 11 times 11 is 121. So that is my answer. 4 chances out of 121 that I would draw one penny out, put it back, and draw another penny. Not very likely. Can you also do this problem on your own? All right, so I'm going to read the problem. Let's see. Evangeline has a jar of marbles with colors listed below. 1 red, 2 blue, 3 green, 2 orange. I'm going to actually, they have a table set up, so I'm going to just use this as my jar. All right, so this is my jar, and how many total do I have? 1 plus 2 is 3, plus 3 is 6, plus another 2 is 8. So I have 8 total. All right, so let's figure out. We want to find out what the probability that she will pull out a red, replace it, then pull a green. So we're going to pull one out, put it back, and then pull out another one. So 2 different events, so compound probability. All right, so the probability of pulling out a red first, is, let's see, 1 out of 8, because the total in the jar is 8. And we're going to multiply that by the probability of pulling out a green. So there's 3 green out of 8 total. So let's multiply those together. 1 times 3 is 3. 8 times 8 is 64. And that is our final probability. If we needed to put that into a decimal, we could, or percent, by 3 divided by 64. If we change this to a percent, we can see that that the probability of pulling a red, then pulling a green in that order, is only 4.7%. So it's very close to 0%. So that is very unlikely that those two things would happen. All right, so now we are doing the back side of this sheet, and we are doing problems without replacement. So we are going to do problems without replacement. That means if we take something out of a bag or a box, we are not going to replace it or not put it back. All right, so Maddie has a bag with 5 red Skittles and 4 green Skittles. What is the probability that she picks a red, eats it, then picks a green? All right, so the first probability of getting a red. So I wrote my probability of getting a red, then a green. So the probability of getting a red is 5 chances out of the 9 total things that are in the bag. So 5 ninths. Then we're going to multiply the second probability by that. So now, remember, now these are problems without replacement. So when we put our hand in the bag, we're grabbing 1 Skittle, and that's all we're trying for. And you have to pretend we really did get the red one we are trying for. So now that red one comes out, and now we only have 4 red Skittles. We have to adjust our total. We have 8 total in the bag now. So you have to adjust your bag so now you get the right probability for the second event. Now we're going to put our hand in the bag, and we are going to draw out a green. So we have 4 chances, but now our total in the bag is just 8. So our probability of getting a green is 4 out of 8. All right? So now we're going to multiply those two probabilities together. I can actually reduce 4 eighths to 1/2 because 4 is half of 8. So I'm going to go ahead and do that. So 5 ninths times 1/2 would be 5. 5 times 1 is 5. 9 times 2 is 18. So my answer, my probability of those two things happening is 5/18. All right, so now I've got a problem 2. Deshad has a baggie with 1 red Skittle, 3 blue Skittles, and 2 green Skittles. What is the probability that he picks a blue, eats it, then picks a red? All right, so I'm going to total what's in my bag. I forgot to do that. 1 plus 3 plus 2 is 7. So see if you can do this one on your own. So we are trying for first a blue, then we're going to eat that, and then we're going to try for a red. All right, the probability of getting a blue. First one's easy. So we have 3 blue out of 7. So the probability is 3/7 that we get a blue. Now we're going to eat the blue one. So we have to just adjust what we have in this bag. So if we eat the blue one, you have to pretend you're only picking one out at a time. So we got the blue. So now we only have 2 in the bag. And our total of Skittles in the bag is now 6. All right, so now we're going to put our hand in and try for a red. So how many red do we have? Well, we have 1 red. So 1 out of our total of 6 Skittles in the bag now. See how it went down from 7 to 6. All right, so 3 times 1 is 3. Ooh, that's terrible. Is 3. And 7 times 6 is 42. Now we can reduce that a little bit further because 3 goes into 42. So I can divide by 3, and that's 1. And 42 divided by 3 is 14. So our probability is 1 out of 14 chances. So that is unlikely. Which is approximately 7%. So very unlikely. All right, see if you can do this on your own. See if you can draw the jar with the pennies, nickels, and dimes, and then figure out your probabilities. And don't forget to adjust your jar because you're not going to replace the nickel when you pick the first one out. All right, probability of getting a nickel is 2 out of 6. I'm going to go ahead and reduce that down here to 1/3. All right, then we're going to multiply that by the probability of getting a dime. But when we take the nickel, we try for the nickel, we're going to pretend we got it. So the nickel comes out because we do not replace it. It says not replace it. So now we only have 1 nickel. Oops, 1 nickel in the jar. So now, and we only have 5 total. So don't forget to adjust your jar. So now when we try to pick out the dime, we have 2 chances. So we have 2 chances out of 5 total things in the jar. All right, and I'm going to bring my 2/5 down here. So 2/5. So I reduce 2/6 to 1/3. So 1/3 times 2/5 equals 2/15. So 2 chances out of 15 that we could pick out a nickel and not replace it, then pick out a dime. Oh. Next problem. Problem 4. A jar has 2 pennies, 4 nickels, 5 dimes. What is the probability that Ariadne will randomly pick out one penny, not replace it, then pick out another penny? Try this one on your own and make sure you draw your jar. All right, so we are going to try to find out the probability of picking a penny, putting it back, then picking out another penny. All right, probability of the first one is 2 pennies 2 chances out of 11. So I have two pennies. So 2 chances out of 11 total of drawing the first penny. Then we are not gonna put it back, so we have to adjust our jar. So now we only have 1 penny and 10 total coins in the jar. All right, now we're gonna put our hand in and try for another penny. Well, that is 1 chance out of 10 total things in the jar. So now we multiply the probabilities. 2 times 1 is 2. 11 times 10 is 110. And we can reduce that, divide by 2. It'll be 110 divided by 2 is 55. So 1 out of 55 chances to get a penny, not replace it, and pick out another penny. All right, so see if you can try number 5 on your own too. And you can actually just use this chart as the jar, but make sure you put your total on the outside. All right, so last problem. So I have my jar of marbles, and there are 8 total. What's the probability of picking a red marble and not replacing it, and then pulling out a green? All right, so picking out a red. There's 1 red, so 1 out of 8. So 1, out of 8. So I put that right here. Now we are going to multiply that against our next probability of picking out a green marble. But if we're not going to replace it, then we have to adjust our total. So now we picked out the red, and now we don't have any red in the jar. So 0 red, and our total is now 7. So now we're going to try to pick out a green, and there are 3 green. So 3 chances out of 7 total marbles. So then we're going to multiply those probabilities together, and we get 3 out of 56. And we actually cannot reduce that.